Okay, good morning. Who's ready to talk about food? Hopefully you've all had breakfast or not too much to eat. We're going to talk about all sorts of things today, not just what we connected to the internet, but Amazon and Internet of Things, and a lot about food. And you can see Ryan and I are quite serious about food. We both are quite passionate about cooking and making food. We'll see. So we dressed the part today. So we all know, I think we all agree that the Internet of Things is here. Do you want to put it down a bit? Or up a bit? Okay. All right, thank you. So it's here, and it's so rapidly being adopted. It's really quite amazing, the sorts of things that we've seen being connected to the internet, and they're all creating data. They're all creating data that can be visualized in Tableau. So you've got all of these, health devices, your Fitbits, your iPhones, the Apple Watches. You've got huge, industrial devices, which is where Ryan comes from. So the wind farms, these are all generating data and sensor data that can be acquired and visualized. And we have customers actually acquiring data from these sorts of devices. Obviously, the transportation devices, the cars, they're all creating data these days. We've got even medical devices, and I know we've got members of the audience from the medical, healthcare community. There are actually devices now that are creating and sending data that can be implanted in people. And then you've got one of the bigger areas, you've got your smart homes, connected homes, all sorts of devices in our homes and facilities that are creating data. And then you've got, within the sort of home area, you've got devices, cooking devices even, that are creating and sending data. I'm not sure who would be crazy enough to sort of connect their cooking device to the internet. But let me introduce myself. My name is Robin Cortes, and I connected my brick oven to the internet. So I live in New Jersey, so a lot of people think of New Jersey, and some of you are from New Jersey, and you think of the turnpike and the traffic, but I live in this part of New Jersey. It's in the northwestern part, and this is what it was like a few weeks ago. Pretty much, we're coming to the end of fall now. It's what it's like. So this is my brick oven. It's in my backyard. I'll tell you a bit more about it later, about why it's connected to the internet. But I built this around about 2003. So it's 13 years, 14 years. It's been working. It's still standing. I'd never laid a brick before, but I really like baking bread and pizza, and so I built this in the backyard, and it's used for both bread and pizza, and we'll see some of the sort of techniques that it's used. Size-wise, it's about the baking area inside that oven where you see the flames is about 32 by 36. So it's big enough to bake about 15 loaves of bread at a time, or 2 or 3 pizzas right in the front of the oven, just like your local pizzeria. Quite often I have people over, and I'll make about 15 to 20 pizzas for a whole crowd, and then bake bread. And that's one of the pizzas that came out of it. So I'm definitely crazy about bread and pizza. My co-presenter is crazy about another type of food, and I'll let him introduce himself and explain his craziness.
Thank you, Robin. So if you can't tell by the picture and by our ridiculous outfits, I am also crazy about food, but my passion is smoking meat or roasting meat sometimes too. So you can see here, Robin talked about being crazy. If that guy doesn't look crazy, I don't know what doesn't. And also, one thing you'll see throughout here is this guy also really likes it that I smoke meat. You'll see, so Robin had one device that he hooked up to the internet. I actually have 2. So I have my smoker on the left and my grill on the right. For those of you, everybody knows how a grill works. I'll talk a little bit about a smoker just really quickly to give you guys a feel for what's going on inside of my type of smoker. And again, this guy is very common throughout pictures here. I, similar to Robin, also live in New Jersey. I don't live up in the mountain areas like Robin does. I'm down at the shore. So it's not like the Jersey Shore that you see on TV. This is actually the nice area. Those people are not from New Jersey. Actually, most of them from no offense, Sally, Long Island. So yeah. So I'm really passionate about what I'm doing with my smoker and my grill because I like to know how I can optimize the quality of the meat for my guests when they come over. And the reason why this presentation, Robin talked a lot about different IoT devices out there and how people want to use sensor data to really get value out of what's going on in the world that they can't see. I come from the distribution world, the supply chain world. I worked at Anheuser-Busch back when I got out of college, so I did a lot of ops management. And we spent a lot of time trying to figure out where we had down bottle problems, whether the pasteurizer was working or not. And that was a lot of manual work to go out and get the data from the sensors. Or you had one specific program that you can go to and you could try to figure out how to pull the data and eventually get it into Excel and eventually put it into Access and maybe into SQL Server somehow if you really got lucky. After that, I worked at a company called ID Systems, which was focused on forklift material handling, making sure that you have you're using your equipment and moving material in the most optimal way. So again, very focused on sensor data. So although I'm going to talk about fun stuff like meat, we want to make sure that you guys know this is very relevant for anybody who is looking to make more use of sensor data. Out there, just out of curiosity, how many of you guys have sensor data in your environments, in your work environments? How many of you guys how are you, well, I won't ask that question, but how many of you are actually using that data or harnessing that data currently with Tableau? Okay, good. So there's a lot of opportunity now for you guys to kind of see what we did and see if you can relate it back to your own workplace. So just to talk a little bit about the science and what's going on in my smoker, I have an electric smoker. You're going to see the theme throughout this is Robin built from the ground up. I cheated. I chose to go with, I got a lot of off-shelf stuff, and then I figured out how to connect to that. My smoker is similar. You see a lot of smokers around here in Austin where it's usually all either coal-fired or wood-fired, and you have to adjust vents a lot. You have to go in and out of your house to make sure that the temperature stays right throughout the whole smoking process or roasting process. In my case, I don't have a ton of time. I work long hours. I have an 18-month-old. I have a dog, my wife. So when I want to smoke something, I want to make it so that I can set it, get it all prepped, and let it go. Well, my smoker works where I have on the bottom here, there's a housing where the wood sits. So I usually tend to use either hickory or mesquite wood or apple wood. And there's a metal rod that heats up. It's a heating element that gets the smoker to a certain temp, gets the wood to smoke slowly over time, and then the meat sits above it. And I can hold about 40 pounds of meat in here. So it's a really nice contraption. I'd recommend, if you guys don't have a ton of time, electric smokers are wonderful. So what we're going to talk about, I talked a little bit already about the process of going end to end. How can I get to my sensor data? How can I get to my IoT data into Tableau? And the basics when you start are very simple. It's, hey, how quickly can I get my data into Tableau? And you'll see it's just, anybody have Fitbits? Anybody have, okay, great. Nest, Home, yeah, exactly. A lot of that stuff has very easy ways to get to the data, and I'll talk about that. The next step is going to be if I want to see this data in more real time. I don't want to have to take a dump of it and then visualize it. I want to see it as things are happening. How can I get there? So really getting more to real-time-ish access. Then Robin is going to talk about what if your device doesn't come with a data feed? How can you then get that into Tableau? How can you then get access to that data? And then how do you leverage all the Tableau APIs? And we're going to talk about this throughout. This is not only discussing IoT, it's also a good discussion on extensibility in Tableau. How you can use the different extensibility options that we have out there, the ones that have been around for a while, like the REST API and JavaScript API, and then the more recent releases of like the Document API, the mobile bootstrap that we talked about yesterday. So we'll give you guys a feel for all that. And then at the end, we really want to know who you think is crazier, either Pie Guy or Meataholic, myself. So this is my device that I use to connect to the internet. Again, I bought off-shelf, it's called Tapacue. It's a great little device that has it's Wi-Fi enabled. It connects through my modem up to their cloud servers, and then I can look and remotely monitor the temperature of my meat anywhere when I'm running around town. Really great device. At the end of it, if I choose, I can get a CSV dump, and then I can then visualize that in Tableau. So this is the basics. This is I have a device that can give me data, collects the data, and send it to me afterwards. So the workflow that we'll talk through really quickly is I have the temperature probes. My TapIQ device goes either into the meat that's on the smoker or the grill. Then it goes through my router up into the TapIQ cloud. And again, I have that app that they have out there. It's a great app. It gives me my information that I need at the time to see what the temperatures are. And then at the end of my smoke, I can then pull the data down into a CSV file. I put it up in the Google Sheets, and then I connect that to Tableau server, Tableau online, so I can visualize it for myself wherever I am. And what is this used for? So this is going to be, so just to give you a better feel for what it looks like, what am I talking about when I'm saying I'm using those probes? For those of you who don't cook a lot, I just want to give you a feel for what that looks like. This is a pork shoulder. Anybody have pulled pork this week? Everybody pretty much, or a decent amount of you? This is what it looks like raw. So when I'm going to try to monitor the temperature of the pork shoulder, I put probes in a couple spots into the meat, so into the middle of the meat here, into the outer rim, and then an ambient probe. Ambient probe is obviously for me to know what's going on outside, inside the smoker, but outside the meat. The middle is going to give me the true temperature. I want to make sure it gets to a certain temp to finish. And then the external is, it is very important if I want to make sure everything is the same throughout, that by the end of the cooking process, that it's all the same temperature. I don't want it to be really, really, like, especially with things like prime rib, you don't want the outside to be brown and the inside to be red. You want it to be the same color throughout if you could, the same cooked temperature. So that's why I'm monitoring those. And then within Tableau, you can create polygons, and you'll see after as I can monitor the temperature throughout the inside, the outer rim, as well as the ambient temp to get a feel for what it looks like over time. So what I did for this in order to visualize my data, just because this is a Tableau presentation, so we want to make sure we show you guys some Tableau, is I as tomorrow I'm going home, I maybe want to roast something or smoke something. So I can see here that these are the types of meat that I cook. So I cook a lot of pork in my smoker, which makes sense, as you guys probably have learned this week. I want to use a smoker. I could see, okay, it looks like I've done mostly pork shoulder. So I want to understand, well, how much time do I need to smoke my pork shoulder? It's 22.3 hours on average, it looks like it's been taking. So I can then see, oh, here's the different smokes that I've done. This one, for some reason, took a lot longer. So we can investigate that a little bit further if we'd like. So if we then go and take a look and see what happened during this smoke, what I learned from this, and again, my point here is I want to optimize the quality of the meat. Well, when it takes 20 hours, when I did this, I actually had to go out and buy pulled pork because this wasn't done until way after all my guests had left. So you want to make sure that you have the right temperature. And this, again, insights through data, I thought I was just monitoring my data, and I could see a little bit over time what the temperature looked like. But my smoker, actually, when I had it set at 220, it never got above 205, 203, 205. So I had to bump it up to 230 to get to the temperature that I wanted. So really quick insights. And again, this is using just a very simple CSV dump afterwards. So going back into the flow that I'm following here is okay, now that I've got a feel for what historical usage I have of when I'm cooking, next step is I've got a lot of people who come over to my house. This is my backyard. So I've got a lot of people, and they're looking at this big monitor, and they don't really care about historical data. They want to know what's happening now. So if I want to have them see what's happening now up here on this board, I need to figure out a way to get more real-time access. I can't do it with historical data that's dumped to me afterwards. So how can I do that? Well, TapIQ, we follow the same data flow here, but TapIQ actually has a REST API that they were kind enough to give me access to for this presentation. And what we have now is, I'm not sure if anybody uses the Web Data Connector out there. Anyone? Not yet? Okay, so the Web Data Connector is a connector that's available through Tableau where you can write your own connector to RESTful services, to anything that's out there that you want to connect to that we don't have a connector for. And there's actually a really good presentation coming up that we'll talk about after that you can go check out if you want to deep dive into creating some Web Data Connectors and what it takes to do that. But it's essentially, it's some HTML and JavaScript in order to connect to whatever RESTful service you have out there. So I wrote a web data connector that connects through that RESTful service, and then bring the results of the web data connector into Tableau, and that gives me my real-time data. But the other piece that gets this, like I showed you before, there's an app for TapIQ that gives me the current temperatures, and that works pretty well. But again, my guests don't care about what the current temps are. They want to know when they can eat. So to do that, I need to look at historical data to get a prediction of, based on my previous cooks, when is this cook going to be finished so that I can eat. So to do that, we joined up with the web data connector results with the historical Google Sheets data that we had, and then we bring that data into Tableau. And then to make it more real time, we then have, first off, to refresh the data. You want to refresh a web data connector frequently. For those of you who use Tableau a lot and use data extracts, when you're running refreshes, the minimum time that you can have set for refreshes is 15 minutes. So obviously we want to hack that and get around that. So we just wrote a quick script using tab command that allows you to refresh extracts as you want. We set it at every 2 minutes on a Windows task scheduler. And every 2 minutes, this data flow refreshes, and I can get the most recent data. And then finally, if I want to refresh the view, I don't want to have to hit the refresh button on Tableau. So we just use the JavaScript API. There's a simple call for a refresh data async, and it refreshes the data in real time for me so that now I have the ability to show my guests what the temperatures look like over time, when this is going to be done. So it's going to be done around 11:30 p.m. for the current smoke that's out there. It's currently the temperature for me, again, bringing other data within my viz so I can know what's happening outside, whether I want to go hang out outside, should I stay inside and watch football, and then also over time, what does that temperature look like? So getting all of this data between the web data connector as well as Google Sheets. The other thing I could do too is if I'd like to see this remotely, because again, it's important for me to be able to run around town, I can also look at this on my phone. Let me grab this real quick. All right.
Is it seeing it?
Yeah, it's got it.
No,
Now.
Tableau.
We're good.
Oh.
Yeah, we're good.
So how many of you have used the Tableau mobile app? Yeah. So several of you. So this is...
Oh, my son wears funny hats too.
Hey.
Like Robin mentioned, we're using the Tableau mobile app here, and now I can see that other viz that we were looking at before on the mobile device, but also using the mobile device, mobile-specific dashboarding, the device-specific dashboarding, I can now come out and see a live view of this hitting the server in real time, and now this is optimized for mobile, where I can scroll through, see the important stuff that's relevant to me when I'm running around town. So I can see what the temperatures look like on the different probes, whether or not I need to go and adjust the temperature on my smoker to make it more accurate, and then again, see what this looks like so that my guests can see in real time what they can expect at the end of the session. And again, just to point out, he's also hungry there too. So yeah. So now if we then come back into here, again, now, like I said, no longer do my guests have to see me cooking the historical data. They can now watch and see what's going to happen in real time. They can monitor it remotely with the mobile app, or they can see it on my backyard lawn. So with that, again, I want to make sure you guys know, yeah, we're talking about fun stuff, but this is something that you can relate to any type of RESTful service that you have the ability to connect to. A lot of times on shop floors, people want to be able to update the information on the shop floor in real time to see what different machine centers are running and what's coming out of the different machine centers and what do the totals look compared to your forecast. And you could do that with just connecting to that device or to that sensor data and then visualizing it in Tableau up on a big board. So with that, I'm going to pass it back to Robin. He's going to go through his flow.
So you'll notice the theme between bread and meat here. So we've got nice transitions, so you can tell when I'm going to talk because you can see the bread. This is all food that we've made, and some of it we made in preparation. We did a lot of practicing of this session. And a lot of the practicing was actually cooking food and eating it. So it wasn't just the Tableau side. So
we actually convinced our teams in the North New York, New Jersey area to come into our office last week. We just bribed them with pulled pork that I made, and Robin made some nice fresh buns. So we had them come in and we did a dry run of this.
So as Ryan was saying, he uses his temperature probes to measure temperature while his food is cooking, so he knows when it's prepared. But why would I connect my brick oven to the internet? What's the relationship? What's the key need for temperature information for a brick oven? So the science behind mine is that a brick oven takes a long time to heat up to get to it. It's not just like turning on your oven at home and waiting 30 minutes for it to get to 400 degrees. I sometimes have to start my brick oven, with wood, hardwood, overnight or the day before, because you spend possibly 10 hours or more heating up the oven, because there's a lot of mass, and so that the wood fire gets soaked up into the surrounding bricks and concrete in that oven, and it soaks up so that when you're ready to bake, you take out the fire and the heat gets reflected back over several hours. And that's how they've been baking bread for 2,000 years. The design of this oven is based on a design that if you go to Pompeii, you will actually see a brick oven of this style. And people actually build these ovens a bit larger than mine for commercial artisan bakeries. They're doing it all over the world now. So it's not just home bakers. There are actually commercial ovens based on the same premise. So it's nice to know what temperature your oven, all the different parts of the oven are getting to over time. So it's kind of the reverse of Ryan's, where he wants to see the heat at different parts of the meat. I want to see the heat at different parts of the oven to make sure that it's getting spread out and stabilizing over time. So that's why I connected the brick oven. And then, so you're heating it up. You can see right inside, this is after several hours, it gets so hot inside, it burns off all the soot inside, all of the carbon gets burnt off because the inside of this oven gets so hot. And I'll explain a little bit about how we collect that information. So I obviously didn't buy my brick oven off the internet like Ryan did. He's got a good excuse why he bought his stuff. He's got a 1-year-old. He's got a good, but I didn't buy my brick oven, and I didn't buy my sensors. I had to sort of build them. But I have connected up to the AWS, the Internet of Things framework that we're going to talk about. So if I didn't buy my oven off the internet already able to be connected, then maybe I could buy something like a Tapacue. In my case, it's not so easy because a Tapacue is meant for meat, and my oven gets up to thousands of degrees of temperature. And so what I did was built using a Raspberry Pi, a pie, of course, because we like pizza, but and actually, when I built the oven, I embedded thermocouples or temperature probes inside the oven way back in 2003. So I did build them in at the time. It's as if I knew I was going to come and give this presentation 13 years later, so it was very prescient.
And we are lucky, by the way, that Robin's here. He was going to bring that through security.
So this is the actual device, yes, this Raspberry Pi, and the thermocouple is what I call breakout boards, and the wire is collecting, it's the wire that's embedded in the oven. And I was going to bring and show how it actually worked real time, but I looked at the black box sitting on my desk, and I looked at the wire here, and I thought, well, I don't know, should I take that in my backpack or not? Will I actually get to Austin? And I have to admit that I right at the last moment, I don't think I'll try.
My accent's not that good.
I didn't,
so.
Yeah, I didn't bring it. So it's pretty messy, but it's actually really quite easy to even though these are sort of like looks kind of like electronics and hardware and stuff like that, it's still kind of Lego. still connecting components together, and it's the same for the hardware and it's the same for the software. So these are, for your, on the serious side, for your, you out there doing this sort of thing, your colleagues in your businesses are building these devices and actually putting them into your wind farms, your computers, your healthcare devices. This is exactly what they're doing. It's exactly the same pattern in terms of the hardware and the software and the data flow. And so there is a serious intent to doing all of this. I just got to have a lot of fun, looking at the other end. So this is a schematic of the brick oven. The bricks, obviously, it's got bricks, but all of that mass on the outside is concrete. And that soaks up the heat when you're firing the brick oven. And my probes were embedded at various depths in the surrounding area of the brick oven. And once I saw that Ryan could do a polygon, I copied his idea, and I can actually highlight the different areas where the probes are using Tableau. And actually, we can collect the data and actually show the heat. So this is just showing the location, but later on, we can connect the data to it and show it in a visualization if necessary. So we've connected it to the AWS. How did we connect it to the AWS? And what does AWS as a platform provide for the Internet of Things? So who is familiar at all, have done any with AWS as the whole platform? So several of you might be familiar with creating EC2 instances, which are like virtual machines, servers out on AWS. But today, AWS is a whole platform of services and capabilities for processing data from many sources, not just the sensors. It's a database platform, it's a processing platform, and now it is an Internet of Things platform. They announced the Internet of Things components last year at reInvent in October. And if you're interested in seeing, when they introduced it and learning a little bit more, you can go and watch the keynotes from reInvent, actually. So AWS consists of a whole list of services. This is starting to look a bit like the whole list of data sources that Tableau supports. There's a lot. But all these services do different things. And we're going to talk about some of them today and how they relate to the Internet of Things and processing data. So in terms of the Internet of Things platform, so it's a service that AWS now has that is designed to support these remote sensor devices. So devices that are out in the world, distributed, usually wirelessly connected to the internet. So your wind farms, the cars, remember, the fit health devices, and of course the brick ovens. They're all can be connected to Amazon. So they can send data up into Amazon using wireless protocols, messaging protocols, which you can take advantage of and securely connect to the cloud, to AWS in this case, and send data on a periodic basis. And in fact, the Internet of Things framework itself in Amazon is designed to support these devices. And the reality of these sorts of devices that we're talking about is they're not always connected. They're usually very small devices embedded in a consumer device or an industrial device that are not easy to go out to. It's not easy for Siemens to go out or GE to go out to their wind farms and just change and update the software or the firmware on those devices that are sitting out in the bay, or millions of cars. And so this whole framework is meant to support devices that can be very simple, but very disconnected or very distributed across and very wirelessly connected to the cloud. And so, but it needs to be secure. And once you get the data into AWS, you want to process that data, and so there's a rules engine as part of the framework that says, what am I going to do with this data? And now that rules engine is very easy to change, and so you don't have to go back to the device. You can actually update, and I'll show you some of the steps that I went through to update the rules that determined what I did with the data, and I'll show you some examples of the data too. And that can then integrate and send data down. If you think of a pipeline or a flow, that can send data to other services, to other destinations, if you like. Mostly data destinations, like S3 as a sort of object or file store. So is everybody familiar? And hopefully you've heard of S3 on AWS? Yeah, that's a sort of file or object store. And then obviously the database destinations. Amazon has Redshift, it has Oracle, SQL Server in their RDS platform, and even Hadoop, like Amazon Elastic MapReduce. And then a lot of the other data platforms themselves are now on the cloud. So Cloudera, Hadoop, Oracle, they're all having cloud versions which can sit on top of the AWS, and so they can be your database destinations. Lambda is a special, interesting case. It's not a database. Lambda is more like a processing engine. So, and it's a bit like, you can compare it to EC2, where EC2 is like creating a virtual machine or an instance of a computer, of a server. Lambda is serverless, but it allows you to write code that gets executed as part of the flow of data from typically not just Internet of Things, but typically other areas too. And so that brings data downstream, down through a pipeline that's now very accessible to Tableau. These are sort of typical Tableau data sources. All right, so let's drill into a little bit about how we connected up the Raspberry Pi, my brick oven. This is the real flow. The Raspberry Pi is sitting connected to those thermocouples. There are 5 thermocouples, and I can also read the ambient temperature of the brick oven with the Raspberry Pi. And it has some code running on it. It's like tens of lines of code. This is not something that takes a lot of effort to actually prototype and get up and running. Using Node.js, which is JavaScript, believe it or not, and it sends the data up wirelessly to AWS. Based on a cycle, every few seconds, it sends a whole data packet up there to AWS. And then AWS sends it on through this rules engine. And the first thing that I did was to send the data to S3. So that's just, again, it's very easy to do through a management console on AWS. It didn't take any code. It's all point and click, just like Tableau. It's all point and click to set up this flow. And I ended up, the data that comes from the Raspberry Pi is in JSON. So you might have seen some of the earlier sessions, especially the devs on stage, where in 10.1 we've added JSON file support as a data source. So I was able to take that data that came from the Raspberry Pi as JSON and bring it through all the way to Tableau desktop on premise, or on my Tableau desktop. So on the left, that is the sort of raw data that comes from my brick oven. It's got the business data, if you like. You can think of as the temperature, but it also has metadata about data about the hardware, whether you're getting a faulty reading or whether there's even a probe or a thermocouple connected. So that's what some of the extra data is, apart from the temperature. And then we can look at that in Tableau directly with the JSON file reader and see an example of a single data set from a packet of data from these 5 probes. So you'll see we've got the temperature data. We've got some flags which are part of the hardware information telling us which probes are connected. In this case, there was only, because this was, at this point in time, this was when the Raspberry Pi was sitting on my desk and I was testing it. Only one thermocouple was connected, so there's only one device that didn't have a fault flag. The rest I can filter out, and we'll see how we'll use that later on. So we can get hardware device information as well as the sort of actual sensor data itself. Okay, so once we get the data into Amazon Internet of Things, we start collecting it, we want to start getting to the data. We want to connect Tableau to the data. So we've done it with S3. My next step was to say, well, let's imagine scaling this up. Imagine I've got like thousands of brick ovens. Maybe Ryan and I are going to, in our next life, we're going to open up a pizza and barbecue restaurant, and we'll franchise it. So, or I will sell my brick oven on the internet. The shipping charges might be a bit hard with sort of Prime or something like that, but I'll sell it connected. You can connect my brick oven. You buy a brick oven, you can connect it to the internet. But imagine you want to scale this up. We want to productionalize this prototype. And so a typical next step in collecting data from the Internet of Things, from this whole infrastructure, is to put it into a database. Like maybe it's Redshift, or in my case, I sent the data on from the Internet of Things framework into Postgres, which is RDS, which is another Amazon cloud database. And I did it with Lambda because there was at the time when I did this, there was no direct rule to send the data into Postgres. So I've got a little Lambda function, and we can look at the code. I will drop the code. We're going to share the code later on as part of the developer track for those of you who are interested. I'm not going to go into much code today, or hardly at all. But that, again, that's a JavaScript process. It could be Java, or it could be Python, that actually takes the data from the IoT framework and just regularly runs and collects the data and then sends it on to Postgres. So it's transforming that JSON data into a SQL database, which is the more typical data source for Tableau. So that's what that pod does. It's all in the cloud. And then it goes to a Tableau server. Now, my first instance of doing all of this was to send it to a Tableau server, which is in theory on-premise. In reality, this is an on-premise Tableau server that is actually running on an EC2 instance in the cloud, so it's actually all still in AWS, but it could be on-premise. So I'm reading the data from as a live data source from Postgres. All right. So once it's in Postgres, it's very typical database connection, but while Ryan, it was literally minutes for him to do his, to get a CSV from his, because his cloud connectivity, his TAPAQ device was doing that very quickly. I did have to build out that the pipeline, but in reality it only took a few hours to actually build that whole pipeline with the Raspberry Pi and start getting the data up wirelessly. It's remarkably powerful. These cloud tools and the Internet of Things connectivity tools today are remarkably powerful. So as well as Ryan connecting his sensor data to the device data, I also joined the data. So in my relational database, in my Postgres database, I've got metadata or reference data about a cooking session, if you like, and I could join that right in Tableau and visualize the data very quickly. So we're just using Postgres as a data source at this point. So you can think of that whole upstream process of the Internet of Things. Obviously, you as Tableau creators and visualization creators would usually think of that whole process as a black box. You don't have to care what happened. But I think because this is such a burgeoning area, I think it's interesting for us as Tableau people to know a little bit about what's going on upstream, on how we can get data from devices directly via databases and kind of see what's on the other side, to see how powerful and how capable this platform is becoming and how integrated Tableau can be with it. So, so I built a that's a viz. This is one of my first vizzes of getting the data from my brick oven. So this is real data, and you'll see I've got probes that are very close to the heat source. So it's going up to thousands of degrees. You can see at one point that a probe that was very close to the fire, but not just very close, but still embedded in the brick, got up to well above 1,200 degrees Fahrenheit, and it's it gets really hot in that oven. When I first started baking, you bake with like hardwood, just like wood that you would put in your fire at home. I experimented with wood pellets. If anybody's got a sort of wood pellet fire at home, which are really very efficient, I thought I'd see what would happen. And one day, I sort of started piling in wood pellets to see how the oven would get hot. And it wasn't doing much, so I piled in more wood pellets. But after a few minutes, they really caught fire. And I don't know if you've seen the movie Backdraft, but that's literally what happened. It got so hot, it sort of like blew out, and so I singed my eyebrows. So it did happen. So once we've got the data into Tableau through the Internet of Things framework, we can start looking at all of the integration points with Tableau and the extensibility APIs that Tableau comes with. Because this is a developer track, and it's a Tableau conference, we do want to show how, once you've got this data into a form that's accessible to Tableau, we can start taking advantage of all of the Tableau extensibility capabilities. So Ryan has already showed you, and I've showed you, looking at the data in Tableau desktop. We've seen the mobile app. You can also embed visualizations in a portal. And so that's the sort of next stage that I went to. Once I had the data available on the Tableau server, I was able to use the JavaScript API to embed views in a server. I don't know if we've got that. All right. So this is a web server, a portal. Think of it like a SharePoint, or if you have a content management system. A lot of you are exposing Tableau data to external customers or internal with the web portals. I mean, are some of you have that already with Tableau? Yeah. So this is just an example of that. So once we've got the data, we've got a little portal. Oh, this is where the mouse disappears. It's not showing the mouse. So. That's right. It's on the other screen. That's why I can't see it. So I've got that same visualization that I created. I put it into a dashboard, and then you can use the JavaScript API to embed that visualization into a web page. Now, so this is not, strictly speaking, anything to do with Internet of Things, but it just shows how we can downstream start to leverage the data that we're collecting from our devices and expose it, make it available to a much broader audience, whether it's inside the company or our external customers. So this is my data in a web page. And this is actually, although the oven is not on at home, this is a session that happened in September. When this is connected live, this is a dashboard. This is actually updating on a regular basis. It's actually updating every 10 seconds and going back to our Postgres database and picking up the data that is coming from the oven in real time. So I don't know if you can see it, but down below, this JavaScript API application is designed not to show spinners, the Tableau refresh spinners. It's actually updating in real time by hiding a viz behind using the JavaScript API and then updating. Sorry. So it is actually updating. And you can interact with it. So you might have seen the clock change, but you can actually interact with this viz using JavaScript capabilities. So that did update the viz, or I can look at another session. Even though we've got two vizzes behind each other, you can actually connect and update. Okay, so what do we do next? The next thing you might do with the typical Tableau application is you go into production mode, or you sort of scale out or scale up the whole infrastructure. So Tableau itself, you know, can run on clusters and can scale out. But typically this upstream sensor process is obviously something that can scale very significantly. And we can take advantage of that sort of real world scalability and requirements for governance and going from development and prototyping to production platforms by taking advantage of some of the other API capabilities. In this case, we used the document and the REST API to migrate data from one Tableau server to another. And with the new document API, if you've been looking at any of the announcements this week and some of a little bit earlier around 10.1, you can actually update data source connections programmatically. So you can actually migrate a whole workbook and update the data connection to point to another database. So in this case, what I did was with the document and the REST API, and again, now it's getting to be a few lines of code because we have wrappers in Python and other languages coming. So I migrate on the AWS side, I migrated my database from the primary PostgreSQL database, which is getting written to create a read-only replica of that database. That's something that a lot of customers do for reporting and analysis, and that's something that AWS does out of the box. And so I migrated my Tableau Viz workbook from one server to another, and at the same time upgraded the database connection. And we actually put the data workbook on Tableau Online, which, if you remember, Ashley in the Devs on Stage keynote mentioned that we now have the ability to put Tableau Online. We have a Tableau Online, what we call a pod or a region, inside AWS. It's actually running in AWS. And so that's what I migrated that workbook to with the REST API. So they're all connected. We don't have to go much into the code. This is the sort of code that will drop, but this is a piece of Python code that it does the migration of the workbook and the data connection all in a few lines of code, and then you can run it programmatically or from a command line. All right, so the next thing is, so Ryan showed you the mobile app. So that's the Tableau mobile app. It's been out for several years now, several versions. What we've also just announced is the mobile app Bootstrap. So that is the ability for our customers to embed Tableau visualizations in their own mobile apps. If they've got a corporate app and you have the ability to create corporate applications, mobile applications on iOS or Android even, you can actually now write apps and embed Tableau in it. So I got to do that as part of this process. So the AirPlay's not showing up. So okay, so we'll just go to the next screen. We're running out of time. It didn't show up. Yeah, don't worry. So this mobile app allows you to create a native, iPhone or iPad or tablet app and embed Tableau visualizations in it in a very similar way that you can embed visualizations in web portals. Except in this case, the app is a live mobile app. And so you can actually create an app that runs on the desktop. And so a lot of people who have mobile device infrastructures like to create their own apps and manage access to their infrastructure that way. That's something that we've announced this week and made available for you all to sort of build mobile apps without being core mobile developers. So without having to know Objective-C or the whole Xcode workflow, you can actually use an open source framework called Cordova and then for Apple Ionic, there's frameworks that allow you to expose web-type views embedded in a mobile app. And it's actually very powerful and very easy to customize. I don't pretend to be a programmer. I'm a sales consultant, but I was able to take the bootstrap and actually do this, again, in a matter of an hour or so, and customize the sample that they sent. So we've got customized the icons and things. All right, so end-to-end, this is my flow. So not only was I able to connect my device, my thing, my brick oven to the internet and send the data up into AWS, up into the cloud very easily, I was then able to send it into Tableau and leverage all of the Tableau APIs. Ryan leveraged the web data connector, so we've kind of brought together all of the capabilities, and this is the sort of thing that you can do with your sensor data, without necessarily having to worry about how it got to the database, but having that understanding that it can be done, and it is being done in many customers today, bringing it all together. So we did the JavaScript API and the mobile device and the REST API and reading JSON file sources. They all were able to come into play as something that you can do. So these are the sorts of examples that we've done. Once we've connected them between Ryan and I, we've basically nearly used all of the API capabilities, but not all of them. We're working very hard in making Tableau extensible and able to sort of run on the cloud and in the cloud and connect to the cloud. So hopefully that's a good example of what we've been able to do. But it does beg the question, between us, who is crazy? We were thinking about getting you to vote, but there's no real prize for either of us to do it. But we really did want to. We would have liked to have bring some samples for you today, but a bit like the.
We didn't know if the Board of Health would let us.
Yeah.
So we were going to have you sign a waiver, maybe. We were going to do jerky and biscotti because they travel well.
Yeah. So. One of the things that we learned is, although we have a different interest in food, we did learn that bread and meat really do go together very well. So, like Ryan said, we actually did some practicing. So I baked some light brioche rolls, and Ryan one day brought in some smoked pork to our office in New York, and we actually got some of our coworkers to test it, and I think it tasted quite good, if I say so myself. Sally's giving a thumbs up. She got to sample it. Okay. So we can stop there, and we can answer any questions that you have about food, about the Internet of Things, about Tableau. We're happy to answer anything. Hi. Sorry. So we're running. We've come to the end of the time, so I know there was one or two questions. So I'm happy to. We're both happy to answer questions if you want to stay over, but we'll let you go because this is time. So thanks a lot. I hope you're going to have some barbecue and some bread. Thank you.